This video is brought to you by mywayteaching.com.
The following next consider the problem. Okay, the following concentrations were obtained for the formation of ammonia from N2 and dinitrogen and dihydrogen at equilibrium at 500 Kelvin. Okay, so dinitrogen, there is a continuation of this question, is equal to 1.5 into 10 raised to minus 2 mole. Okay, and dihydrogen is equal to 3.0 into 10 raised to minus 2 mole, and ammonia is equal to 1.2 into 10 raised to minus 2 mole. Calculate the equilibrium constant. You know formula about of equilibrium constant. Calculate equilibrium constant. Okay, I will write down the solution here. You know equilibrium constant. Before going to that, write down the general equation, equilibrium equation. Okay, and you know equilibrium constant Kc is equal to product by reactant. So product is NH3, right, and its coefficient is 2, and the reactants, that is dinitrogen, and this is dihydrogen whole raised to 3, and put note, they given the value 1.2 into 10 raised to minus 2, this is whole square, divided by 1.5 into 10 raised to minus 2 into 3.0 into 10 raised to minus 2 whole cube is equal to 0.106 into 10 raised to 4 is equal to, this is after calculation you are getting the equilibrium constant Kc is equal to 1.06 in 10. Here nothing is there in this problem. They have given the values and they are asking to find out the value of Kc. What is Kc? So you know product by reactants, and we are raising this one. We are writing here equilibrium constant. So coefficients we are writing, this is power 1. Okay, this is the problem. Next, consider the problem number 2. At equilibrium, the concentration of, at equilibrium, the concentration of dinitrogen is equal to 3.0 into 10 raised to minus 3 mole. So dihydrogen is equal to 4.2 into 10 raised to minus 3 mole, and hydrogen oxide is equal to 2.8 into 10 raised to minus 3 mole in a sealed vessel at 800 Kelvin. What will be Kc for the reaction? Again, what will be Kc for the reaction? Okay, so I will solve here the problem for coefficient. They are asked, we know that the equilibrium constant Kc, this is dinitrogen, this is oxygen. So you know Kc value is what they have given, NO value, N2 value, and O2 value. Okay, after putting the values of this, NO is 2.8 into 10 raised to minus 3 divided by N2 value is 3.0 into 10 raised to minus 3. O2 value is 4.2 into 10 raised to minus 3. After solving, we are getting 0.622. Okay, this is the answer. Next, what is homogeneous equilibria? Okay, in homogeneous system, all the reactants and products are in the same phase. That is called as homogeneous equilibria. All are in the same phase. Okay, just I will consider one example. See, this is dinitrogen and this is dihydrogen, which gives ammonia. This is also gas. So here these are called reactants and this is called products. So all are in the same phase in a gaseous state. So this is called homogeneous equilibria, homogeneous phase. Okay, next, equilibrium constant in gaseous systems. What is equilibrium constant? What happens in equilibrium constant in gaseous system? We know that so far we have expressed equilibrium constant of the reactions in terms of molar concentration of the reactants and products are used symbol Kc for it. We are using equilibrium constant to Kc, right? Kc is the symbol. For reactions involving gases, however, it is usually more convenient to express the equilibrium constant in terms of partial pressure. We know the ideal gas equation. The ideal gas equation PV is equal to N into RT. Okay, where P is equal to N divided by V into RT. Here P is the pressure in a Pascal. P is the pressure. N is the number of moles of the gas and V is the volume, and where T is the temperature in Kelvin. N by V is concentration expressed in molar per cube. If concentration C is in mole per liter or mole per dm cube and P is in bar. So that P is equal to N by V. We can write this as C concentration and this one is R into T. We can write P is equal to gas into RT, where here R is equal to 0.0831 bar liter per mole bar liter. R is equal to 0.031 bar liter per mole Kelvin. Okay, at constant temperature, the pressure of the gas is proportional to its concentration. So, at constant temperature, the pressure of the gas is proportional to its concentration. Is okay. So this is the equilibrium constant in gaseous system. At constant temperature, pressure of the gas is proportional to its concentration. Okay. Next, in general. Similarly, for I will write in general, like general liquid reaction. DD. So keep, is equal to BB. Okay, and A plus B. Okay, so RT, you write C plus D minus of A plus B. Okay, and next you can write like RT. Okay, you can write that is A plus B, C plus D minus A plus B. You can write it as delta N. Okay, that is equal to Kc into RT whole raised to delta N. This is equal to Kp. See, once again I will write that is Kc RT delta N. Okay, where delta N is equal to number of moles of gaseous products, number of moles of gaseous products minus number of moles of gaseous reactants. Reactants. Okay, if the then in a balanced chemical, it is in balanced chemical equation, it is necessary that while calculating the value of Kp, pressure should be expressed in bar because standard state of pressure for pressure is 1 bar. Okay, and we know from that is we know that 1 Pascal is equal to, okay, and 1 bar is equal to 10 raised to 5 Pascal. Remember this one. Okay, next, you just now studied about homogeneous equilibrium. In the next part I will explain you in detail about heterogeneous equilibria. Okay.